Hello, my dear students. I am Rajkumar Kalia, working with Brindaban Group of Institutions, situated at Main Bagnuru Road, Yalanka, Bangalore 63. In my free time, I am uploading videos for you people so that you can enjoy without paying anything. And whenever you are free, whenever time is comfortable for you people to see, you can use that time. So in turn, I am getting good subscriptions. So kindly keep on doing all these things. So today I am continuing the Diploma Model Question Paper 2020 Karnatka Board. First and second semester examination engineering mathematics. See particularly subject code is 20SC01T. That's for the fresh diploma you are going to get this paper. First four sums I have solved. Fifth sum is first four I have solved. The fifth sum is express 75 minutes in radian meters and 3 pi by 2 in degree meter. Solution 75 degree, 75 minutes. Converted into degrees, that is 75 by 60 degree. Because 1 degree is of 60 minutes. So it will come out to be 75 5s are 75 4s degrees. To convert degree, to radians, multiply the degrees, multiply the degrees by pi by 180. So therefore 75 minutes, 5 by 4 in degrees, 5 by 4 into pi by 180 in radians. So solve it. 5 3s are 6. So pi by 144 radians. Like that you are supposed to solve this sum. Then come to the second part, 3 pi by 2 in degrees. 3 pi by 2 in its radians. To convert radians to degrees, multiply radians by pi by 180. So therefore 3 pi by 2 radians. To convert radians to multiply it by 180 by pi. Multiply it by 180 by pi. So we will get 3 pi by 2 into 180 by pi degrees. Pi we can cancel, 290 the, so 270 degrees. So to convert radian to degrees, just multiply it by 180 by pi, and degrees to radians pi by 180. So like that we can solve this sum. Its B part is prove that cos A plus B, cos A minus B equals cos square minus sin square. LHS cos A plus B into cos A minus B. Use the identity of cos A plus B, cos A cos B minus sin A sin B. Cos A minus B, cos A cos B plus sin A sin B. Cos A cos B minus sin A sin B, cos A cos B plus sin A sin B. Use the trigonometric identities. Then see here, if I take it as A and B, I will get A minus B and A plus B. And the identity we know is A minus B into A plus B is A square minus B square. So use that identity. We will get it as A square means cos square A cos square B minus sin square A sin square B equals. Now see, cos square A is required, sin square A is not required. We need cos square A, and we need cos square A and sin square B, but we don't want cos square B. For cos square B, put 1 minus sin square A or sin square B. Then sin square B we need, sin square A we don't want. Put it as 1 minus cos square A into sin square B. Just see, cos square A is required. I am keeping it as it is. Cos square B is not there. To cos square B, I have changed it into 1 minus sin square B. Minus sin square B I need. I am keeping it as it is. Sin square A I don't want. I have converted it into 1 minus cos square A. It's from the identity sin square theta plus cos square theta equals 1. So I have used that identity here. Now open the brackets. Cos square A minus cos square A sin square B. Now multiply negative sin square B minus minus plus cos square A sin square B. equals cos square A sin square B negative, cos square A sin square B positive, we can cancel. Thus we are with cos square A minus sin square B. Hence proved. Like that, we are supposed to solve this one. Fifth C part. Show that cos 2 theta equals 2 cos square theta minus 1. We know cos A plus B equals cos A cos B minus sin A sin B. We know this identity. Let A equals theta and also B equals theta. We will get cos for A theta, for B theta. For A theta, for B theta. For A theta, for B theta. It will come out to be cos 2A. Cos A into cos A cos square A, sin into sin square A. RHS, sin is not there in the RHS. Cos 2A, cos square A, sin can be written as 1 minus cos square. Sorry, it's not A, theta plus theta, 2 theta, 2 theta. Cos square theta minus sin square theta is 1 minus cos square theta. From the very first identity, that is sin square theta plus cos square theta equals 1. I have used that identity. Cos 2 theta cos square theta minus 1 plus cos square theta. Cos square theta plus cos square theta, 2 cos square theta minus 1. Hence proved. Like that we are supposed to prove this. Very simple. See, this sum is related to allied angles. First concept is, if change is with 90 and 270, remove co, add co. We are not getting it. Second, if angle is more than 360, subtract 360. Like here. It's more than 360, just subtract 360. So it's the same as sin 120 degree, cos 330 degree, sin 240 degree, subtract 360, that is cos 30 degree. Here we can write the concept we have used. Cos 390 degree is the same as cos 30 degree by subtracting 360. Then never change the angle with 90 or 270, because then co-rule will come and you may be in trouble with sin also. Go in a simple way. Sin, put it as 180 minus 60. into cos 360 minus 30 minus sin 180 plus 60 cos 30, that value we know directly. Cos 30, that is root 3 by 2. Put this value directly. So like that. Now come to the quadrants 0, 90, 180, 270, 360, and with all sin, tan, cos. Use this rule now. 180 minus 60. 180 minus 60, second quadrant. In second quadrant, sign is positive. Thus it is simply sin 60. 360 minus 30, fourth quadrant. In fourth quadrant, cos is positive. So thus cos 30 degree minus sin 180 plus third quadrant. 180 plus is third quadrant. In third quadrant, sign is negative. So we are supposed to put here minus sin 60. 180 plus 60 is minus sin 60 degree. Into it is 3 by 2. We have already solved. Then sin 60 root 3 by 2 cos 30 root 3 by 2 minus minus plus sin 60 root 3 by 2 into root 3 by 2. Thus we are getting root 3, that is 3 by 4 plus 3 by 4. Thus 4 LCM, 3 plus 3, 6 by 4, thus 3 by 2. So which will be the answer? Just conversion, and try to avoid always 90 and 270. See the next way. Find the value of sin 15 degree. Sin 15 degree can be written as sine of, you can write 60 minus 45 or 45 minus 30. It's your wish. Say 60 minus 45. 60 degree minus 45 degrees, 15 degree. That's like sine A minus B. Use the identity of sine A minus B. Sine A cos B minus cos A sin B equals sin 60 root 3 by 2 cos 45 1 by root 2 cos 60 1 by 2 sin 45 1 by root 2. Thus it will come out to be root 3 by 2 root 2 minus 1 by 2 root 2. So 2 root 2 LCM, we will get root 3 minus 1. So that will be the answer. So easy is this sum. 6th B, simplifying cos 360 minus A, tan 360 plus A, cot 270 minus A, sin 90 plus A. This sum is related to again the quadrants 0, 90 degree, 180 degree, 270 degree, 360. Now its solution is cos 360 minus a. Cos 360 minus a, that is in fourth quadrant. In fourth quadrant, cos is positive. So thus it will be cos a. Here we will get cos a. Tan 360 plus a. If angle is more than 360, just subtract 360. I mean we will get tan a. Just subtract here 360. Cot 270 minus a. If change is with 90 or 270, remove co and add co, we have this concept. 270 minus, so 270 means remove co of the cot. It will come out to be 10. 10 of A. Come to the quadrant. 270 minus A. 270 minus A is third quadrant. In third quadrant, 10 cot positive. So sine will be positive. Sine 90 plus A. Changes with 90 in the beginning, add co. Sine to cosine. That is cos A. 90 plus A. 90 plus A is second quadrant. In second quadrant, sine is positive. So it will remain as it is. So thus it equals cos A we can cancel, tan A we can cancel. Answer will come out to be 1. So simple is this sum with the concept. If changes with 90 or 270, add co, remove co, and add sign according to the quadrant. Six C part. Prove that sin 3 theta is 3 sin theta minus 4 sin cube theta. Proof, or you can say the solution. LHS is sin 3 theta. Put sin 3 theta 2 theta plus theta. Now it's like sin A plus B equals sin A cos B plus cos A 2 theta sin B, that is theta. Now see the RHS. We are not having cos. This sin 2 theta and theta are single only, not multiple. Sin 2 theta. Put it as 2 sin theta cos theta. Then one more cos theta is there. Plus cos 2 theta can be written as 2 sin square theta minus 1, identity of cos 2a. Then sin theta. Here I have used the identity that cos 2 theta is 2 cos square theta minus 1. This identity I have used. 2 sin square theta cos 2 theta cos square theta minus sin square theta, and we want in terms of sin. 1 minus 2 sine square theta. Cos 2 theta is 1 minus 2 sine square theta. So for cos 2 theta, put here 1 minus 2 sine square theta equals 2 sine theta cos theta into cos theta cos square theta minus plus 1 into sine theta minus 2 sine cube theta sine square theta into theta 2 sine theta. We don't want cos in RHS, so to put the value of cos square theta as 1 minus sine square theta sine theta minus 2 sine cube theta equals multiply 2 sine theta minus 2 sine cube theta plus sine theta minus 2 sine cube theta. So we will get it as 2 sine theta and sine theta. 3 sine theta, 2 sine square and 2 sine square minus 4 sine cube theta. 2 sine theta and sine theta, 3 sine theta, 2 sine cube theta with negative sign, 2 sine cube theta with negative sign, which will give us minus 4 sine cube theta. So that is the identity. Learn it like identity, you may need it.